Welcome back to the pod. This is season 2, episode 7, MTP number 6, Build Procedural Fluency for Conceptual Understanding. Welcome back to the podcast. This is season 2, episode 7, MTP number 6, Build Procedural Fluency for Conceptual Understanding. For this episode, I am your GM, Kira, and I'm here with...
Lilia,
Lola,
and Nan.
So I'm going to start with our overview of MTP number 6 with a quote from the Principles to Actions book saying, "Effective teaching of mathematics builds fluency with procedures on a foundation of conceptual understanding so that students, over time, become skillful in using procedures flexibly as they solve contextual and mathematical problems." Which basically means that students should have access to multiple means of solving so that when they are down the line and they are, like, they have an understanding of the concept that they're dealing with, say it's like multiplication, based on a problem and based on the context, they're able to use different methods. So to use math effectively, students should do more than just carry out math procedures and learn the standard algorithm. They have to know what procedure is going to be appropriate for the situation that they're in. And the reading outlines a sort of fluency sequence, like the process that students go through before they become fluent or even have the capacity to become fluent. Mm-hmm. And it's exploration and discussion of number concepts, then using informal reasoning strategies based on meanings and properties of the operations, and then use of general methods as a tool in problem solving. So I guess that last one would be like when they're sort of getting fluent and they have the sense of numbers to know, like, oh, I shouldn't use a pie chart here, or I shouldn't use a tape diagram here. And an idea that they talked about very briefly in the reading that I thought might be important to just bring up as a bigger concept is math anxiety. Ooh. So, thank you for that.
Yeah,
I feel honored.
It's very, prevalent in our society.
So, according to the reading, math anxiety is caused by rushing to fluency instead of taking time for students to develop confidence in the concepts. So, if you're just giving students a bunch of problems and you're like, do them, and we're going to do them every single day, and then you guys are going to be fluent, and then we're going to move on, that's super that's super quick. Not giving the kids the idea of, oh, I'm a learner, I'm a mathematician. I'm taking the time and the patience to sort of learn this concept. Because if they're not confident in the math, they're not going to feel confident using other methods. Additionally, they're not going to have the time to develop an actual interest in math, which I feel like is hard, just as a general idea, getting kids to care about math and actually have a deep interest in it. But that's something that has to start in kindergarten, because if they have an idea that they're not learners and they're not good mathematicians, that they're not going to care. But to actually taking the time to have students be confident in what they're doing, actually care, engage them in activities that are connected to understanding, then they'll be less likely to experience anxiety around math.
Also, just want to jump in. What you were saying was amazing, especially with kids that are diverse. I think we can also add that it's going to be also hard for them just because they're also learning. They're just learning about this now, and they can't. If it's too fast for them, they're not going to understand anything, and they're not going to do they're not going to be good in math. So I feel like fluency is very important, especially for kids who cannot speak English or need a lot of more support. Because at the same time, you would also need to explain it in a way that they would understand, and I feel like it's hard because you have many different students who are at many different levels in their academics or in math in general, that it's hard to be able to explain it so that they all understand. And I feel like maybe you might have to do some groups or be hey, this is exactly what I'm talking about, maybe a group where students are kind of in the same exact level, so maybe 4 groups, and then just talk to them in very different ways, during it, after when they do independent work, or just when you have time.
Yeah, it's so important to take into account your audience, your students, because just saying you can't go too fast, you can't just rush to fluency, that is important, but some students do learn faster than others, and some students learn slower than others, and that's not bad. It's not bad that they learn slower. It's not good that they learn faster. It's just that's just the way that they learn. So knowing who your students are, having a good classroom environment where everyone's comfortable, there's respect, there's rapport, and you're able to have the sense enough to use ability groups like Jenna was saying, and like break it down like that, and you know, hopefully you have enough hands or time in the classroom so that like students can learn at their own pace. And it's especially helpful when the kids are like pulled out for math instruction, or you have a para, like you're able to go at a pace that the students are going to resonate with best. Like they're gonna be able to take it at the pace that they learn at best, and then get into fluency. And the thing about procedural fluency, and specifically the standard algorithm, and they talk a lot about the standard algorithm in this reading, and about how not all the students are going to get it. This quote says, students begin fluency by using objects, visual representations, and verbal counting, and then they progress to reasoning strategies using number relationships and properties. So you can't immediately just expect students to be able to reason, like just giving them a problem. Being able to connect something like the standard algorithm, which at first glance, without having that understanding of multiplication, which is the example we're going to be running with for the rest of this podcast, they're not going to immediately be like, oh, like, duh, it's 54 times 7, which I just said that backwards, but whatever. Like, I just do 7 times 4, and then blah, 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 blah. Like, that's not intuitive. Yeah. Like, connecting problems like that to a visual representation is very important. Also, leading into application of the MTP number 6 is varying the written notation of the problems. So like I was saying, you can't just do the standard algorithm and be like, here's the standard algorithm, now you're all super good at multiplication. You have to have different you have to have multiple means of written representation of problems, and that's vital for understanding and actually developing procedural fluency. There is an upcoming example problem that I'm going to share that compares two 4th grade students' approaches to the multiplication problem 54 times 7. One student, David, he misuses the standard algorithm, which was like kind of my example before. And then the other student, Anna, breaks down the equation into parts. So she multiplies 4 by 50, and then she does 4 by 7, and then she adds that 228 together to get the product 228. Meanwhile, when David was doing the problem, he did 7 times 4 in the standard algorithm, saw that it was 28, 8 down the bottom, carried the 2, and then added the 2 to the 5. So then it became 7 times 4 again, and he got the answer 288. So if you're just not representing the standard algorithm in a visual way, the students might not understand, and they're going to carry on in a way that they think. Because I think, from my understanding, he probably mixed up the standard algorithm for multiplication and addition, or like thought he was supposed to add.
With all the signs, it can be so confusing too. Just memorizing all of it, and plus this is all kind of memorization.
It might be that it's like area, you know what I'm saying? Like
exactly.
With an array model, it kind of looks like you're just multiplying, right? You're not going to be adding, because if you have like for example, if you had like the let's say 50 and then the 7, right? It's like, oh, but do I multiply 50 times 7? But he doesn't know that represents 57, because you have to add. So it's like very confusing for students. So I totally understand that.
Yeah, like having the different ways to see a problem broken down. Honestly, since we're in the flow of like talking about visual methods, I'm just gonna skip talking about practice problems. I'll say it briefly though. Like there's such a thing as too many practice problems, as too few practice problems. You have to have just the right amount. You have to integrate them into different ways, so that you also have to give them feedback. Sorry, did you remember it? Give them feedback on that, so that students don't end up solving problems in a similar way that David did, and continually go forward and like misunderstand the use of the algorithm.
Learning the wrong way. Learning how to do it the wrong way over and over and over again.
I have a comment on the practice problems. I feel like in high school, whenever we would learn, like, I feel like this is like algebra, and whenever we would learn something new, I legitimately would be doing my homework, and I would be doing it would be like the same format of a problem, like 50 of them. And like, it would be like, I would be doing them, and it would be like I'm on autopilot. Like I memorized the way to do it, and I'm like, I'm just doing it. Like it's mindless almost.
Exactly.
Once
you don't think about it.
Yeah, and you're like it was like textbook problems, and I'm using only one way to solve it, and it's literally like autopilot. I don't
Yeah.
know. And I don't remember any of it now. Like, was I actually learning? No.
Yeah, I don't remember anything. I remember some things, but like the things that I had to memorize, I don't remember.
And I feel like you always just remember that one method or that one strategy that you use, and then it's especially hard when the teacher's like, okay, can you show it in a different way? You're like, oh,
Like,
damn,
wait,
I
what?
can't, I don't know how to do that. You know what I'm saying? And like that's the thing when it comes to like building procedural fluency, that you have to make sure that they're fluent in every single procedure and every single different types of method. Because if you just focus on one, they're only going to learn one, and then when it comes to MCAS or when it comes to other testing, it's going to be very difficult for them to.
Yeah, because if they're just focusing on that one, on just the standard algorithm,
Right.
they're not, unless you're like actively working with them, they're not going to see that there's easier and more, the word I'm thinking of is escaping me, but like a quicker way to solve things. Like, you know, we can look at 57 times 4, and when you're in 3rd grade, you're like, wait, like this is hard. But as adults, you can be like, oh, well, 50 times 4 is 200, and 7 times 4 is 28, so the answer is 228. And like, you can kind of flex if you're a math genius like me, and on your friends and be like, wait, I'm actually super smart.
Yeah.
But that's why, sorry.
Oh, no, sorry. I was just going to say, like, speaking of that, like, wanting them to do a second choice, I like asking, like, the younger kids, choose your second favorite option. Like, instead of doing, like, choose, like, the way that they would normally solve it, I like, I'll do, like, solve it one time like that, and then for the next problem, choose your second favorite. Like, something like that.
Yeah, like varying it.
Yeah, very.
But at the same time, like I understand why teachers sometimes just specifically focus on that one specific method.
Yeah,
because
so
when
they
it
can
comes to
master
state
it.
testing.
Yeah.
Yeah.
It's like that's the only way that the state testing is asking, like what MCAS is asking.
Yeah.
It's like, what if that really doesn't help them? Like, what if that's just, like,
problem,
not
and
the
that's
way
not
that
fair.
they
And I
can
feel
do
like
it?
then this goes into the system or the mathematical community. That's where it just goes, and you're like, oh man, like students should be able to do this, and that's where teachers have to figure it out, and it's a little difficult for that.
But like, relating the book back to like all of our general comments on this is practice needs to be brief, it needs to be engaging, it needs to be purposeful, and it needs to be spread out. Because if you are giving your students assignments like Lilia has received, and they're just doing like a bunch of different, like whatever, you know, it's different when it's like a math minute or a mad minute, whatever, and you just like do it once and it's just like keeping them sharp. Like that's one thing, but like if all of your homeworks, all of your activities is just the same method over and over and over and over, it's not, you're not getting to the point where it's like, oh, like it's mindless in the sense that I know how to do it, so I'm just gonna keep doing it. It's mindless, it's like I don't care.
Yeah.
Like I don't care about this, I don't understand what this is, I just know I have to do it
It's
for a
just
grade.
a chore, yeah.
So like a practice should be targeting specific strategies. The example that the book gives is making a 10 for addition, or doubling like a known fact for multiplication. Like I'm trying to think of like a more specific example because like that doesn't really make sense now that I've read it out loud.
No, I'm just trying to figure out what that is.
Yeah, like probably like referring to like a tens and ones chart, because this reminds me of working with my best friend Daniel at my sped placement, because we're doing addition problems like based on word problems, and they're like breaking it down into tens and ones charts. And so like it, like the problem was like, I don't know, like 74 plus like 68, and so like you do like the 7 tens and then like the 4 ones and then like the 6 tens and the 8 ones, and then he counts all the ones and sees that there's 10. Then you move them into the tens category, and then you see, oh, there's more than 10 tens. You move that into like the hundreds category, I guess. Like breaking it down.
Yeah,
like I don't know,
step by step, like scaffolding every step.
it's hard for me to explain. I don't know if I've ever used a tens and ones chart, so like seeing that
I know,
like with him, I was like, oh, okay.
Interesting.
An example of using multiple methods of solving a type of problem, again, we're sticking with multiplication, is there's an image, and I wish that I could project this image into your mind, Dr. King, but I can't, so I'll describe it in detail for you. It's referencing a problem 68 times 46, and it's showing it in 4 different methods. And the first method is an array model, which it breaks it down into a rectangle. I think that day in class we were all using different methods, like the array model, and you have to like divide up that one section into like smaller parts when it's like ones.
Yes.
That's one way to do it. That's similar to the open array model, which is the second way that it represented it. So instead of just having like the numbers like in an open array model, the array model like specifically divides it into different size blocks to like show the numbers and you can count it. But the open array model is like expanded multiplication, expanded standard algorithm. So you're seeing, if we're going to continue with our 68 times 46 example, like in the big rectangle, you do 60 times 40, which is 2,400, and then 60 times 6, which is 360, and then 8 times 40, 320, and then 8 times 6, 48. I'm totally doing this off the top of my head, not reading the thing at all. I'm a math genius. And then it shows the conventional standard algorithm, which we've addressed is kind of confusing. And then it talks about the accessible algorithm, which I feel like, except like doing my own math, I'd never seen represented independently. Because I remember when we were working on open array models in 1070 probably, you would pair that with the accessible algorithm. So instead of just having it written on the actual open array model, we'd also have that 60 times 40 is 2,400. And then like, then you do the 60 times 6 and you like put it in a list, but it has it like that as its own way of solving. And I feel like when we're doing mental math as adults, like that's kind of how you do it.
That's what
like,
I do it.
You break it down into parts. Like because we are already fluent in the different procedures of multiplication, you're able to just like off the top of your head be like, oh, like I think I already gave this example. Oh, like 8 times 6 is 36, and then etc. Because I can totally do that off the top of my head. But this progression of like different models of multiplication supports students in establishing like an idea of where they could apply these different methods, because the standard algorithm isn't always going to work. The open array model isn't always going to work. Like having these different tools in the toolbox, so important,
in the toolbox,
allows them to put it in different contextual situations.
Yeah, and just having them practice it like often.
Yeah, like
Also, just like in general, like I think it's also like important for them to understand like not just the procedure, but also like the terms that they're going to be like learning about, like multiplication. They have to understand what multiplication is. How can you show multiplication? Like how can you use multiplication? What's the correct way? What's the appropriate way? And then if you're using area models or arrays models, right?
Area models.
Okay.
That's right.
Or any other type of model or any other type of method, they have to understand the definition of that method. Like, why are we using that method? When am I supposed to be using this method? When is it helpful to use this method? Because you're not always going to be using that, you know, and maybe it's harder to use it in other examples or other problems. And then you can figure out a much easier method. So students should be able to understand those terms, and I think it's very helpful to maybe have like a sheet where she can write the terms, and she can also write like the different models, and then give them to the students. So
like an anchor chart.
Have them in their little desk, and they can pull that out and be like, okay,
like having it like taped down, like maybe like having it like taped down to the desk or something like as a little like key for them. But I don't know, would that like be like beneficial for them if they're taking a test? I don't know.
But
I don't know.
It works hand in hand. Like knowing the actual procedure and then being able to be fluent, or knowing the actual like concept and then being like fluent in the procedures. Like you can't have one without the other.
Yeah,
and
exactly.
I think this is a beautiful way to end episode 7.
So.
Thank you guys for joining me, and thank you Dr. King for listening. Bye. The credits for this episode is the Principles to Actions book and our MTP final big old document for the class. Thank you.